Welcome to Biology My Passion. I am Soumya Harikrishna. Today onwards we are including chemistry also in our channel. To begin with, class 10 chemistry many students find difficult. The reason is you don't have proper base of that. So many chapters or concepts that we learned in class 9 are base of chemistry. So without learning that properly or without much understanding of that, if you start learning the concepts in class 10, you find it difficult. So I am just giving a few tips or few concepts which are relevant for class 10, which you have already studied in class 9. Okay. So after learning this thoroughly only, you start with the class 10 portions. So basically when we talk about chemistry, we learn that every substance is made up of indivisible particles called atoms. So you know that whenever we are depleting something, break and break and break, finally what do we get? Atom. So initially it was believed that atom cannot be further divisible or indivisible. But later we found that still atom can be divided into 3 subatomic particles. They are protons, neutrons and electrons. So in one atom there are 3 components. Which are they? Protons, neutrons and electrons. So protons are the positive charged particles, whereas electrons are the negatively charged particles. So protons positive, electrons negative, opposite charges. Then what about the third one, neutrons? Neutrons don't have charge. So let us see how are these subparticles arranged in one atom. For that we are using the atom model called Bohr's model of atom. According to Bohr's model of atom, there is a nucleus in the center and there are shells or orbits around this. So within the nucleus of the center, these 2 subatomic particles are present. Which are they? Protons and neutrons. So positively charged protons and chargeless neutrons are there in the nucleus. Now where are these electrons situated? They are revolving in these orbits or shells around this nucleus. So there are definite paths through which these electrons can move. They are called the shells or the orbits. So the shells are different based on their energy levels. The innermost is K shell, outer to that comes the L shell, L, after that M, N, O, P, Q, like that energy level is increasing. So we can represent their energy level as N. So K has an energy level 1, L has 2, M has 3, N has 4, like that it goes on. So whenever you see the number of protons in an atom, usually in a normal atom or the neutral atom, number of protons and number of electrons are equal. That means if there are 10 protons, how many electrons will be there? 10 electrons will be there. Okay, neutrons also will be same. So if there are 10 positive charge inside, there are 10 negative charge outside. So what is the total charge? 0. Okay, so we can consider the mass of proton and mass of neutron equal. They are equal. Whereas electron has negligible mass, so we don't consider. So when we are talking about a concept called atomic number, it is represented by Z. It represents the number of protons. But we know that is equal to number of electrons also. But we usually say it is number of protons because protons are inside the nucleus. It cannot be moved out of the atom. Whereas electrons are the ones which are either going out of the atom or some electrons can come to the atom depending on the need. So we cannot predict or we cannot say the atomic number in terms of electron number because it keeps changing. Whereas protons number will not change. So for an atom, the number of proton is definite. So we call atomic number in terms of number of protons. Now mass, if you calculate, the mass of an atom is calculated by mass of proton plus mass of neutron which are situated in the nucleus. Why are we not considering electrons for that? Because electrons have negligible mass. In order to calculate the number of electrons that can be accommodated in each orbit, we have got an equation 2n square. M represents the energy level. We know K has an energy level 1, L has a 2, M has 3, N has a 4. In that way if you calculate, K shell can have 2 into 1 square, that is 2 electrons maximum. If there is a third electron, it should go to the next orbit. But how many electrons can be there in the next orbit? 2 into 2 2 square, that is 8 maximum. Then the next orbit will have 2 into 3 square, that is 18, and the end shell can have 2 into 4 square, that is 32. This is how we are finding out the number of electrons that can be accommodated in each orbit. In order to learn all the portions in chemistry in class 10, you should know at least the first 20 elements by heart in that order. Okay, so if you know that 20 elements, the atomic number wise, then you can find out the electronic configuration or distribution of electrons from that. How many electrons are in the outermost shell, that is called the valence electrons, and the valency of that. Valency means what? The combining capacity of that atom, that I will tell you how it is, which is useful in making formula, because in class 10 we use lot of chemical formulae. Okay, so let us see 5 each together first. Hydrogen, helium, lithium, beryllium, boron. Okay, so HHLBB. Okay, so hydrogen, helium, lithium, beryllium, boron. So you by hearted 5 each at least one day, the next day another 5, like that 4 days you can finish all the 20, or you can make some mnemonics, interesting mnemonics, and work on that. So first is hydrogen. Hydrogen has got only one proton and one electron. There is no neutron in hydrogen. Atomic number is 1. Since hydrogen is the atomic number 1, it has got one proton and one electron. There is no neutron in hydrogen. That's why mass number is also 1. So there is only one. So where will it be? In the first shell. Only one electron which will be in the first shell, one proton which is in the nucleus. When it comes to helium, its atomic number is 2. So in the nucleus, 2 protons, the 2 electrons will be in the K shell, because K shell can have 2. Then lithium. Lithium, how many are there? Total 3. But K shell can have only 2. So 3 minus 2, 1 is left, that will go to L shell. Then next is beryllium. It will have 2 in the first shell, another 2 will go to the next L shell. Then B, that is boron, 2 in the first shell, K shell, L shell, another 3 will go. So total 5. Now in this M, N and all are vacant, but valence electron we have to understand. So these two are confusing terms, valence electron and valency. Valence electron means the number of electrons in the outermost shell. Whatever be the outermost shell of that particular atom, how many electrons are there? For example, look at the hydrogen. Outermost shell is K. How many electrons are there? 1. Here outermost is K. 2 electrons are there. Here outermost is L shell. Only 1 electron is there. Here outermost is the L shell. 2 electrons are there. Here outermost is L shell, but 3 electrons are there. So this is called a valence electron. How much is the outermost one? So whenever you are writing the last number, that is the valence electron. Okay, now we have to find out valency. So valency means the combining capacity of an atom. For example, I will just give you an example to show that there is an electron called a sodium. Sodium atomic number is 11. Okay, so K shell can have 2. How many more left? 9 are left. But L can have only 8. Now one more is left. That will go to M shell. So outermost is 1. At the same time there is chlorine. Chlorine is 17 atomic number. So first 2, then 8, then 7. For any atom, it is striving or struggling to make the outermost electron or the valence electron 8. 8 is the magic number, we call it as nobody has configured. It is outermost electron 8 means it is satisfied. It does not have to involve in any reaction because it has got 8. So every atom is striving to get 8 electrons, that magic number. For sodium also it's not 8. For chlorine also it's not 8. So both of them will be struggling to make it 8. But for sodium, you know, outermost is now 1. So for sodium, already 11 electrons are there, 11 protons are there. But if it wants to make it 8, how many more it has to take? 7 electrons it has to borrow from someone. So once 7 electrons come in, the total number of electrons will become 11 plus 7, 18. But how many protons are there? Only 11. So nucleus with the 11 protons cannot hold the 18 electrons around it. So it is an imbalance. So Rather than taking 7, or taking 7 is difficult, but giving 1 is easy. Just leave this outermost one out, so that the previous shell L becomes the outer now. Because now this is gone, means this is the outermost, it has got 8. So it's happy. So sodium, instead of taking 7, it is preferring to give 1 to make the outermost 8. At the same time, chlorine. Look at chlorine. Chlorine has 7. So chlorine also seeing sodium. If it is thinking, okay, I can also leave 7, means again there is a great difference. That is not acceptable. So for chlorine, rather than giving 7, taking 1 is enough. So sodium is giving 1, chlorine can take that 1. Right? So if the outermost is 1, 2 or 3, they prefer to give. So their valency also will be 3. If outermost is 4, they like to share. So there is a kind of bonding happening between non-metals, that is called a covalent bond. We will study about it, where sharing of atoms take place. Sorry, sharing of electrons take place. Then next, 5, 6 or 7, what do? They receive. Okay. So here how many they are giving? 1, 2 or 3. So their valency is 1, 2 or 3. Here 4 being shared, so valency is 4. But when it comes here, there is a difference. 5 are there. They are receiving. They already have 5. How many more they have to receive? 3 more. Whereas 6 means how many more it will receive? 2 more to make it 8. 7 means 1 more. So this is the valency. So here in this cases, outermost electron or the valence electrons and valency are the same. Whereas here the valence electrons are different, valency is different. So valence electrons number can go from 1, 2, 3, 4, 5, 6, 7, 8. Whereas valency will go from 1, 2, 3, 4, 3, 2, 1. If it is outermost 8, no reaction, so 0. Got it? So how will we write here? Here what is the valency? 1, because it has 1, it will give 1. Here it has 2, it does not have to react, because K is the outermost shell and it can accommodate only 2. So nothing is possible, so it's completely filled. So it's happy, no need to react. Then here it is 1, it will give 1, it will give 2, it will give 3. Look at the next one, beryllium, boron, carbon. Carbon is 6, 2, 4. Outermost is 4. It will give or take 4. Okay, so this is how the valency and valence electrons are coming. Now let us see the next the atoms, that is after carbon 6, 7 is nitrogen. So nitrogen 7 means 2 and 5. So how many valence electrons are there? 5 valence electrons are there. Will it give 5 or take 3? It will take 3 rather than giving 5. So valency is 3. So outermost simply we write as valence electron. How many are given or taken, that is coming in valency. So next is the oxygen 8. So 2, 6. Valence electron is 6 but valency is 2. Fluorine 2, 7. So here 7 but 1 will be taken. Neon 2, 8. So here 8 are there. So valency becomes 0. Neon is an atom which is stable. It has got 8. Every atom is struggling to get 8, but neon already has 8. So neon is happy. So neon does not have to worry about any giving or taking. So it is 0. Such elements or atoms are called a noble gas configuration. They are all gases, so we call it a noble gas configuration. So up to 10 you by heart: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Okay, so now we will see from how much, that is from 11 to 20. So 11 is sodium, magnesium, aluminium, silicon, phosphorus, sulfur. So sodium is 11, so 2, 8. 8 plus 2, 10, 1. Here, so valence electron is 1, valency is also 1, because we reached up to 0, now we have to again start from 1. Magnesium 12, 2, 8, 2. Valence electron is 2, valency is also 2. Aluminium 2, 8, 3. 13 is that atomic number. Valence electron is 3, valency is also 3. Silicon is 14, 2, 8, 4. So 4 and it will share 4. Phosphorus is 15, 2, 8, 5. 5 is the valence electron, so it will receive 3, so valency is 3. Sulfur is 16, 2, 8, 6. So 6, but it will receive 2, valency is 2. Then chlorine is 17, 2, 8, 7, and it is 7 and 1 will be taken. The next is argon, which is 18, 2, 8, 8. So 8 is there, 0. So argon is the next noble gas. So this is how the valency is and valence electrons are changing. Valence electrons start from 1, 2, 3, 4, 5, 6, 8, whereas valency increases from 1 to 4, then decrease down to 0. We will now see the last two, 19 and 20, which is also there for you to know, but you don't learn the rule for that, how to make it. So let's see. Suppose potassium is the 19th element, so it has K, L, M, N. So K shell has 2, L shell has 8, so 10. Now we need 9 more. Can I write 9 here? Because, can I write 9 here? Here it can go up to 80, we know that. But it's not possible to give us directly 9 here because it cannot accommodate more than 8 until this is filled at least 2. Understood? So what happens is, next 8 will come here. So when 8 electrons come here itself, its energy level will go above n, because n is actually the actual level, n is above m. But when 8 comes in m, it will go above n. Then n will become angry, how can m go above me? So the next electron, when it comes, n is below and it is empty. So the next electron will go to n. N will call electron 1 and make it sit there because m is already above it. Then next calcium comes. Okay, so 2, 8. Here already it's above, n is below, only 1 is there, so it will add 1 more. So 2 total 10. So if 2 is filled, now n is happy. N is more energetic now, it will go above m again. Now it will start filling in m till it get 80. For example, we will see an atom called krypton. Krypton is a 36, so 2, 8. Okay. Here also 80, then here will be 8. How can it fill 18? Because once it fills 2 here, then after that 18 can come, then only the next electrons will go here. So we will take a 21. 21 is scandium. 2, 8. Okay? 2, 8. Here it will be 8. Here it will be 2. So that is calcium. But since it is 2, the next one more can be accommodated here. Here it is now allowed. N will allow M to take more. So it will become 9. So 2, 8, 9, 2. Next will be 2, 8, 10, 2. 2, 8, 11, 2. Like that it goes up to 18, which is the maximum. Then only it will fill the N shell. Imagine this is a pure substance or an element. It has got the same type of beads everywhere, right? So this is called an element. Same type of atom it has got. But they can be of different types. Sometimes that atom or element has only one atom, then it is called a monoatomic. So it exists as individual one atom alone. But some they cannot stay alone, they need a companion. So 2 will join together, like a 2 atoms join together to form the entire substance. So that is called a diatomic. So hydrogen always stay together, nitrogen always stay together, oxygen always stay together. Then triatomic means what? 3 atoms always stay together. That is example is ozone, which is O3. Then polyatomic means starting from di, 2 or more together, how many number we comes, we call them as polyatomic. So this monoatomic is only not coming in under this polyatomic, rest all are polyatomic also. Now, two or more than two atoms combine together, then it is called a molecule. So here we can say this is a molecule, this is a molecule, these are all molecules, but only monoatomic cannot be molecule. So till now we saw these atoms are electrically neutral, but sometimes the atoms can gain positive or negative charge, then we call them as ions. So how are they gaining this? For example, previously I told you about sodium, 2, 8, 1. So what is the number of protons? 11. What is the number of electrons? 11. But we saw the sodium will leave this one electron. So how many electrons now? Only 10 electrons. One it left. So there are 11 plus and 10 minus. So what is the overall charge? 1 plus. So sodium will become Na plus. So sodium gains a positive charge by losing one electron. Whereas chlorine we saw 2, 8, 7. This is, now let us see chlorine. It is 2, 8 and 7, right? So chlorine wants to get one electron. So once it absorbs or receives one electron, it becomes 18 electrons and 17 positive charge protons. So one electron is extra. So what is the net charge? It is negative. Okay, so chlorine becomes negative. So atoms can gain positive charge by losing electrons and attain negative charge by accepting or receiving electrons. So based on that, there are two types of atoms, cations and anions. So cations are positively charged like a sodium, whereas anions are negatively charged like a chlorine. To remember this, what you can do is, here there is a T which is looking like a plus. So you can remember cation is positive. You have to keep remembering certain ions that these elements are forming. Repeatedly when you are using it, you will naturally learn how to do this. Plus 1, for example, sodium, potassium, silver, copper, ammonium, etc. So here you can see that if you know the electronic configuration, then there is no need of by-hearting it, because up to 20 we are learning. So if you write how many valence electrons are there, you know 1, 2 or 3, they will lose, so they will gain positive charge, right? So like that, if you can write the configuration file, that is better. But this is the reference, quick reference, because copper, silver and all we are not studying or coming under 20. So for them only you remember plus 1 and plus 1. Now plus 2, what are they? Copper, zinc, iron, magnesium, calcium. So magnesium, calcium and all we came across, but copper, zinc and iron we did not learn within 20. So remember plus 2. Plus 3, aluminium and iron. Aluminium 13 came, but iron we did not come across in 20. So whichever did not come, like silver, copper, iron, zinc, and these are the ones you have to, copper, these are the ones you have to remember. But again, you may have a doubt, because you are finding copper as plus 1 and copper as plus 2 also. The same way, iron as plus 2 and iron as plus 3 also. Because these are certain elements which will have the atoms with the different valencies or variable valencies we say. Copper can have plus 1 or plus 2. The same way iron can have plus 2 or plus 3. So when you are learning the same small number, we use the suffix OUS. That's, for example, this is cuprous. But higher number is plus 2. So cupric. But for iron, lower number is plus 2. So it is ferrous. Then 3 comes ferric. Okay, this is how we use it. Suppose cuprous oxide or cupric oxide, iron oxide, ferrous oxide or a ferric oxide, like that we say. Then in this, carbonate has a minus 1 we'll see first. Chlorine, bromine, iodine, then hydroxide, nitrate, hydrogen carbonate, all these are minus 1. Whereas minus 2, only 2 we will be using, that is CO3 2 minus and SO4 2 minus, carbonate and sulfate. SO3 2 minus is not coming in class 10. So carbonate and sulfate you have to remember. Then minus 3, phosphate and nitride only. So this is how you can remember. Phosphate 3 minus, so CO3 SO3 or SO4 2 minus, and the minus 1 is this. So the same way here also, if you see the names sodium, potassium, ammonium, magnesium, calcium, aluminium. So if it is ending with the then also you can remember they are plus. Okay, so this way you can use some tricks to remember this, because while using the equations it's very confusing for you to write whether it is 2 or 3 or like that. Okay, so it's easy to remember. We will see how to write the chemical formula or molecular formula of certain substances. Like first one is water. We know water has hydrogen and oxygen. So we write the elements here, H and O, the symbols. Okay, now what will we write? The valency will be written below that. Hydrogen has valency 1, oxygen is 2, because we know oxygen is 8, so 2 comma 6. So since it is 6, it needs 2 more. So valency is 2. Then we have to crisscross. So H2O1, so H2O. If it is 1, need not write. The same way hydrogen chloride. Hydrogen is 1, chlorine is 17. 17 means what? 2, 8, 7. It will take 1. So valency is 1. So H1, Cl1, HCl. Now hydrogen sulfide. Sulfur is a 16, 2, 8, 6. 6 means what? 2 more it requires. So 2 is the valency. So when we crisscross H2, yes, we get. Now calcium, we know calcium is 2, 8, 8, 2. So calcium is 2, oxygen already we saw 2. So Ca2O2. So since both are 2, if you simplify you will get CaO. Carbon dioxide, look here, carbon has a 6 electrons, 2, 4. Out of that 4 outermost shell means valency is also 4. Whereas oxygen is 2. So we will write C2O4. But there is simplified formula we have to write, so it will become CO2. Now ammonia has nitrogen and hydrogen. So nitrogen valency is 3, because nitrogen is 7, 2, 5. Since it is 5 valence electrons, it will take 3 more. Whereas hydrogen is 1. So crisscross N1H3, so NH3. Now sodium chloride, sodium has 11, 2, 8, 1. It will leave 1, so valency is 1. Chlorine has 17, 2, 8, 7. It will receive 1, so valency is -1. So plus 1 and -1, so NaCl. Magnesium chloride. Magnesium is 12. So 2, 8, 2. It will leave 2 electrons. So 2 plus we write. Whereas chlorine receives, one atom of chlorine can receive only 1. So -1. So when we crisscross it will become MgCl2. Then aluminium oxide, aluminium and oxygen we wrote. So whenever one metal and one non-metal comes, we write metal first. So aluminium is metal, here magnesium is metal, here sodium is metal. So aluminium is 3, aluminium is 13, so I didn't write here. So aluminium is 13, 2, 8, 3. So since it is 3 in the valence electron, it will lose 3. So valence is 3, whereas oxygen is 2. So crisscross Al2O3, so that is the aluminium oxide. So when we come to lead nitrate, lead has 2, nitrate has 1. So when we crisscross, lead is becoming 1, but NO3 nitrate as a whole it is getting 2. So don't write NO3 2, it will make only oxygen twice. So that is not what we require, we need NO3 as a whole twice. So we read it as NO3 twice, PbNO3 twice, don't read PbNO3 2, okay. Now NH4OH, NH4 is a +1, OH is -1, so ammonium hydroxide we get. So basically you remember that these groups like SO4 is sulfate, CO3 is carbonate, NO3 is nitrate. These are the ones usually you are using. Nitrate, carbonate and sulfate. So sulfate is 2, carbonate is 2, nitrate is all 1 and OH is 1. So these things if you remember, class 10 portions will be easy. So I have tried to teach you the basics of class 9 which you require for class 10. So in coming videos we will try to see with the lessons in chemistry. So thank you for watching my video. If you like, please share and subscribe to my channel. Biology My Passion.